All right, class, here's another example or an application of the derivative of a function. So I'm going to add this on to section 1.3 because this is where the first time where I'm going to be asking you to find the equation of a tangent line. Okay, I'm going to ask you this question in several other sections. It's an application of derivatives. So again, given harder functions, right, we're dealing with all sorts of more and more complicated function, but the question always will be the same. Find the equation of the tangent line to the graph of, let's say, this function here, which is one that we've just learned how to deal with, when x is equal to 1. So let's see what that means first of all. So I'm going to draw what could look like the graph of this function. So let's say this is almost like a quadratic function. You've learned in your college algebra classes. I might turn 4 times, 3 times, 4 possible intercepts, whatever. I'm just going to make up something. That's about what this graph could be looking like. Okay, so the question here is, what is the equation of the tangent line to this graph when x is equal to 1? Okay, now when x is equal to 1, let's say about here, what will the tangent line to this graph look like? Well, there it is. Yes. Now, my question to you first of all is, do these tangent lines look differently at different x values? Right? So what if I would have said, look at or find the equation of the tangent line to this graph when x is equal to, let's say, 5 or 4. When x is 4, this tangent line definitely looks different, yes, and it will have a completely different equation, yes. Okay, so here it is. That's what I'm asking you, though. Now, to find the equation of any line, what does the equation of any line look like? Well, the equation of a line has this format. You've learned about equations of lines. Equation of a line has the form y equals mx plus b, right? M stands for the slope of the line. B stands for the y-axis intercept, yes? Okay, great. Well, what do I know, or what would I need in order to find the equation of a line? To find the equation of a line, we might need 2 points. Right? 2 points determine a line. You've learned that. Do I have 2 points on this line that I know? No. The only thing I have is 1 point. Okay. Well, fine. So that's not helpful. What else could I be given and still be able to find the equation of a line? I could be given this 1 point and the slope. By the way, you have learned a different formula which you don't necessarily need to remember, but there was something called the point slope formula for the equation of a line, and that's how it went. And we're going to use both. It doesn't matter. You can, again, if that's the form that you have memorized, that's perfectly enough. But 1 point and the slope is really what you need, even with 2 points. Because if you were given 2 points, the first thing you would do is find the slope, right? And then use one of the points, by the way, if you do remember. So, do we have a point? Yes. Which point do I have? Well, I know it's happening when what? X is equal to 1, yes? I was told to find the equation of this line when x is equal to 1. So I know for sure that 1 point on my line or on my graph is the same, right? The common point is where the tangent line touches the graph. So I know that the x-coordinate here is 1. How do I find the y-coordinate of this point? Well, again, this point is common to the line and the graph. So because it's a point on the graph, I know that the y value is simply the function value, right? Plug in, right? This is the function, the red one. So this point here is on my graph as well. So if x is 1, what's the y value? Well, I'm going to plug it in. So it says 3 times 1 to the 4th, right? Minus 4 times 1 squared plus 2. So that's a 3 minus 4 plus 2, which equals to 1. Okay, so I know the point has coordinates 1, 1. So I know the point. Yay. Great. What about the slope? How do I find the slope of this tangent line? Well, that's exactly what we have learned in 1.2 and still practiced now in 1.3. We have learned that the slope of a tangent line to a graph is really nothing other than what? The derivative of that function at that point. Okay, so the slope of the tangent line we've learned, and let me get back to the graph, right? Here's the tangent line, here's a different tangent line. What we know definitely is what? The slope of this tangent line, yes, is equal to the derivative of this function, well, at the point we're looking at, right, 1. What's going to be the slope of this line here? The slope of this line here is also the derivative, but at which point? Well, I drew this tangent line at a different point, right? That x value there is 4. So, of course, it changes because you're plugging in different values, and the graph changes for every x. Well, unless it's a line and it doesn't change at all. So this is what we've learned. Again, the derivative stands for just the slope. So with the derivative alone, all we can find is the slope. If I want to take it further and not just find the slope, but the whole equation of the line, right? The equation that represents this line, yes? Then this is the type of answer that I have to give you. That's the equation of this line, okay? So, again, for an equation of a line, we need a point. We found it. We need the slope. Well, let's go find out. How do I find the slope? First things first, I have to find the derivative. So, what's the derivative of this function? I'm just going to go back up here. Here's my function. What is the derivative of this function? The derivative of this function is 3 times 4 is 12, x to the third, minus 4 times 2 is 8, x, and the 2 goes nowhere, right? So remember, what did I say? The slope at x equals to 1 is specifically the derivative when x is 1. So 12 times 1 cubed minus 8 times 1, that's going to be 4. So that's the slope. All right. So now I have all the parts. What are the parts? I need a point and I need the slope. I have the point. It's 1, 1, right? X is 1. We plugged it into the function, right? And we've got 1 for the y value, and now we have the slope as well. So we can, as I said, I'm going to use both formulas. Whichever one you still have memorized will work. So if you do know the point slope formula, that's great. You can use that. If not, this is definitely one that you have to know, the equation of a line. Yes. So you've gone through too much algebra to get here, so might as well put it to good use. So the point has coordinates 1, 1, right? So it's 1 for x and 1 for the y value, right? Here is my point. And then the slope that I'm going to plug in is 4. We found the slope to be 4. So y minus 1 is equal to 4x minus 4, add the 1 over, right? So this equation of the line is 4x minus 3. That's the final answer. That's the equation of the line. That's done, okay? How could I just get by without knowing the point slope formula? No problem. I know a point, and the point stands in for x and y coordinates, yes? So the y coordinate is 1, the x coordinate is 1. What is the slope? The slope is 4. So plugging in the x, the y, and the m gives me a chance to find the b. So minusing the 4 over, b is equal to -3, yes? But then don't forget, that's just the b. You do need to write the equation of the line. And what's the equation of the line? Y equals to mx, m is 4, so 4x, plus b. So this here is just allowing me to find the b value. And that b value is -3. So as you see, we're getting the same answer either way. Depends on which algebra formula you remember. But either way, it's just really a little algebra application. You've learned how to find equations of lines many, many times, right? And you already remembered one more time what? That to find the equation of a line, you need a point and you need a slope, yes? The point is easy because we are telling you where this is happening. At least the x value. Of course, you know how to find the y value. You plug it in to the function, yes? But the one thing that we're missing is the slope, right? And this is what calculus has allowed us to now further know. That the slope of this tangent line, it has to be a tangent line, yes? Not any random line going through this, okay? It has to be the tangent line. So the slope of the tangent line is equal to the derivative of that function at that point, right? So you find the derivative, plug in that x values, and that's going to get you the slope of that tangent line. All right, so again, this is going to come up several more times in other sections with different functions. We already know how to take the derivative of this function, so here it is. Okay, now go do your homework and you'll know how to do it.